Hello, I'm Aparna Bamzai, University Assistant Director at the South Central Climate Science Center. Today, we're here with Dr. Joe Friday, Professor Emeritus at the School of Meteorology at the University of Oklahoma. Dr. Friday is here to tell us a little bit about the international landscape of climate change research prior to the creation of the Intergovernmental Panel on Climate Change. Thank you for being with us, Dr. Friday. Would you like to tell our viewers a little bit about yourself?
I'm delighted to be here with you today. When I was director of the National Weather Service, I had the privilege of also serving as the United States permanent representative to the World Meteorological Organization. As a result of that, I saw a lot of the beginnings of the activities that are going on to try to better understand climate change and how it affects the world.
Tell us a little bit about how climate change became an emerging research topic in the world.
It's very interesting to look back at history and see what really happened. We recognize the importance of greenhouse gases all the way back into the late 1800s. But it wasn't until the International Geophysical Year started in 1957 and 1958 that we actually started to measure things and to have a better feeling for what was going on. The whole world scientific community came together for that 18-month period of the International Geophysical Year. It was a spectacular undertaking. We studied everything from how the sun interacted with the Earth. The United States and Russia both launched their first space satellites at the time. We observed the Van Allen radiation belts for the first time. But one of the most important things that we did is that the United States built on the 13,000 feet up on Mauna Loa an observing site to measure carbon dioxide. You might ask, why there? Well, the main thing, it was out in the middle of the ocean, so there wasn't a large industrial base around to contaminate the readings. It was 13,000 feet up on the mountainside, and it was on the windward side, but it was above all of the trade wind areas that would affect the local pollution. So it was an area where we could get a completely clean view of what the atmosphere was doing over the Pacific Ocean. And we measured CO2 for 18 months. And it was fascinating because we saw the CO2 begin to increase when the vegetation decayed. And then as spring came along, we saw the CO2 start to decrease as photosynthesis took the CO2 in and converted it to oxygen. After the 18-month observation of seeing the rise and fall of carbon dioxide, it was described by some scientists as being, we have finally seen the lungs of the Earth at work, breathing in and exhaling. And at that time, as often happens, the government said, well, let's close it down. We now understood it. Fortunately, Dr. Harry Wexler, who was the chief scientist of the Weather Bureau at the time, suggested that it might be important to see if there were any changes from year to year. And after a battle of budgets to try to keep that system going, they kept it going for a few more years. And of course, that has become one of the most recognizable geophysical signals in the Earth. And that's that constant breathing of the Earth and the rising all the way from when the first measurements were taken of about 315 parts per million CO2 in the atmosphere to last year we crossed 400 parts per million. And so we have seen that rise. Shortly after that rise was begun to be observed, scientists started to say, wait a minute, this has some implications for us. Because this means that we're going to have a problem in the future if this continues to rise. And the Earth is going to get warmer. And then we started to actually see that in the temperatures as well. And so that's kind of the origin, if you would, of what really became a major issue for us for the entire world.
So how did the United States respond to these startling findings?
Well, the scientific community started to take a look at it seriously. The National Academy of Sciences, for example, put together a group of people to study the implications of carbon dioxide on the climate. This was the so-called Charney Report that was in 1979. And it was fascinating there. I had the privilege of being there as an observer to see a dozen great men of science, and unfortunately they were all men at the time, see the great men of science go in and look at the data and debate it and come to conclusions as to what that might mean. And it was interesting the fact that they indicated that with a back-of-the-envelope computation, that if indeed carbon dioxide were to double in the atmosphere, we could expect approximately 3 degrees centigrade rise in the total global temperature, with somewhere an era between 1.5 one way and 1.5 the other. So somewhere between 1.5 to 4.5 degrees would be the rise would be the rise in the mean temperature of the Earth if carbon dioxide were to double. That's fascinating because with all the studies since then, those numbers are still pretty valid. A lot more detail. We now know, for example, that we're going to see more heating at the polar regions than they are at the equator. And we know that there's a distribution difference between the northern hemisphere and the southern hemisphere because of the landmass. But that overall average balance of 3 degrees plus or minus 1.5 degrees is still pretty true today.
And in turn, how did the international community respond?
The international community started looking at this very seriously as well. The International Council of Scientific Unions started to look at what they can do to better understand what was going on. In 1986, they established an advisory group on greenhouse gases. This was a group of several scientists that understood atmospheric chemistry, that understood the carbon cycle and all of that, to try to provide the ICSU, International Council on Scientific Unions, with a understanding of what the implications were so they could take it back and provide this to policymakers across the world. The advisory group met several times, came to conclusions similar to what the Charney group had come to, and continued to point out the fact that there were serious problems for this planet if we didn't do something about it. Those kind of pronouncements started to gain attention not only from the scientific community, but also from the political community. Also, the fossil fuel industry, for example, suddenly starting to see the handwriting on the wall that this might have an implication to them because the vast majority of this CO2 increase was coming from fossil fuel burning. So we started to now see a divergence between the politics and the science. The politics were trying to say, well, this is probably not going to be a major problem for us. The science was saying the increase in CO2 is going to have major implications, not only for temperature, but also on the sea level, because as the temperature would rise, melting of the ice caps and heating of the ocean would cause a rise of the sea level. This was going to affect potentially millions of people living on the coastal plains of our major cities all the way across the globe. Needless to say, this started to be a major issue. The World Meteorological Organization, in association with ICSU, assembled the first World Climate Conference. It was only called the World Climate Conference at the time. There have been 3 of them now since then, so it's now referred to as the first World Climate Conference in 1979. And as a result of that, there really began to be a major push to do something about it. Politics versus science, still going on today, but it really caused issues to be focused and polarized in many aspects. The advisory group on greenhouse gases, for example, was viewed as a body of people that had no accountability. They could say whatever they wanted to by some administrations, including the United States. And the United States felt that there should be more accountability in these sorts of scientific pronouncements. And so they were pushing to try to provide an intergovernmental type of activity.
So how did all of these meetings end up with a more formalized process for assessing climate change research?
The pressure from the United States and others was to try to have a more accountable process. So instead of having an ad hoc scientific community putting together statements on climate change, statements on the impacts of greenhouse gases and so forth, there began to be a major push for the World Meteorological Organization, the United Nations Environmental Program, to work together to provide an accountable system for knowing what was going to happen in the future, for assessing the scientific information, and for indicating what the impacts of that would be.
Well, thank you so much for your personal insights on this critical period, Dr. Friday. Join us in our next video and we'll see what happened as a result of this critical pressure that was put on the research community.